Yeah, hello student. Today we are going to see current electricity chapter full revision. It's for class 10 as well as 12 also will be very useful. For 10th standard, it is a chapter 12. For 12th standard, it is a chapter 3. Okay, so it's very important chapter current electricity. Okay, if you are preparing NEET or JEE, both the exams, this is very important. Okay, so today we are going to learn full concept from current electricity. Yeah, first one is the defined current. Current is defined as the rate of flow of charge. A rate of flow of charge, we can take it as a current. Okay. In case we have the conductor. Okay. So conductor and the insulator. Conductor have a lot of free electron. Insulator have less free electron. We have the conductor. Okay. So I connected with the battery. I connected with the battery plus minus. So positive is indicate as a defect of electron, negative indicate excess of electron. So negative will be having excess of electron. The electron moving from negative to positive. So electron always moving from negative to positive. Usually we'll know current is traveling from positive to negative. Okay, electron is opposite to the current direction. So current is moving from dash to dash. It's from positive to negative. Okay, ammeter also shows the direction, but electron is moving from dash to dash. It's negative to positive. It's very simple. Current is equal to rate of flow of charge. Okay, current is equal to rate of flow of charge. So I is called current, Q is called charge, T is called time. So I we can take it as the current, Q we can take it as a charge, T we can take it as the time. Current we can measure the unit of ampere, charge is coulombs, time is seconds. Okay, so now 1 ampere is equal to 1 coulombs by 1 second. So define ampere is going to be the coulombs per second. That's called define ampere. Okay, next one. Ammeter is used to measure the current. Ammeter is a device, it helps to measure the current. Second one, voltage. Voltage is defined as the work done per unit positive charge. It's bringing from infinity to one point. We can take it as a potential. We can take it as a potential. Okay. So I'm defining what is voltage. Okay, this definition will be little bit difficult to understand. I'll make you to understand. Okay. So potential, work done per unit charge, bringing from infinite to one point, we can take it as a potential. Same thing, potential is equal to work done per unit positive charge, bringing from one point to another point, which we can take it as a potential difference. Potential difference. So the difference between the two terminal also potential difference we can call. Okay, I'll give the example what's going to happen. Okay, so we have here big container. Okay, big container. Okay, with full of water, filled with water. Okay, here another container I have. Okay, in between I connected with the tap. Okay, it is fully filled. A is fully filled, B is empty. Okay, automatically we know the water will be flowing from higher to the lower. Okay, so till equilibrium position. Same way, the higher potential to lower potential, the current will be traveling. Potential is called voltage. So potential difference or electromotive force or battery or voltage, everything will be the same. Okay, everything will be the same. Potential difference, electromotive force, battery, voltage, everything will be the same. Okay. Now potential difference, the difference between the two terms, we can take it as a potential difference. It's a basic definition. Okay. So otherwise, difference between the two terminal, okay, whether it is a battery, if you are taken a AA or AAA battery, normal battery means difference between the two terminal, we can take it as a potential difference, which is going to call as the voltage. Okay, now we have two definition. First one is the voltage, that's going to be the potential work done bringing a unit positive charge from infinity to one point, somewhere infinite to inside the electric field. This is little difficult to understand. Anyway, in future you can understand. Okay, the charge is bringing from infinity to one point, we have to take it as a potential. Okay, then the same thing from one point to another point, if you are bringing the unit positive charge, which is going to call as a potential difference. Okay, so as we know, from one end to another, one terminal to another terminal, we are bringing the charges, which is going to call as the potential difference. Okay, so now 1 volt is equal to 1 joule per 1 coulombs. Okay, 1 volt is equal to 1 joule per coulombs. So we know the unit of potential will be volt, unit of energy will be joule, unit of charge will be coulombs. Okay, now we are going to learn relation between current and volt. Current is directly proportional to the voltage. So I'll define state Ohm's law. So you need to know what is statement of Ohm's law. Applied potential difference is directly proportional to flowing of current at constant temperature. This has to be the statement of Ohm's law. Okay, relation between current and voltage is called Ohm's law. Okay, when we are removing this directly proportional, wherever you should introduce as a constant. Okay, here constant is going to be the resistance. So V is equal to R times of I. V is equal to R times of I. V is called voltage, R is called resistance, I is called current. Okay, if you want what is resistance, is going to be volt per current. Okay, the unit of resistance, defined resistance means the abstraction offered by the wire, like against force is offered by the wire, we can take it as a resistance. The unit of resistance unit will be ohms, unit of voltage volt, unit of current ampere. So 1 ohms is equal to 1 volt by ampere. Okay, in case define 1 ohms anywhere it's they asked, 1 ohms is defined as the 1 volt per unit ampere, we can take it as a 1 ohms. Okay, so this is called resistance. Now factors affecting the resistance. So already I told you what is resistance, is abstraction offered by the wire. Okay, so what are the four factors is there? First one is the length. Okay, second one is the nature, so factor affecting the resistance. Second one is the nature. Third one is the temperature. Fourth one is the area. Okay, so these are the four factor will be affect, sorry, nature, temperature, area. Okay, these are the four factor will be affecting. First we will discuss about length and the area. Okay, first we will be doing with length, how it's going to affect the resistance. Okay, we'll take it smaller length and it will be taken as a longer length, which will be offer more resistance. So yeah, first length or second length, second length will be offering more resistance. Why second one is offering more resistance? Because when the current is flowing from one end to another end, the electron has to travel, electron has to cross many protons. So that means compared to 1 and 2, second one have more proton, more abstraction will be offered. So if length is increased, resistance will be increased. In this case, you can have directly proportional, because when the length is increased, resistance will be increased. That is called directly proportional. Okay, so the next one, area, how the area will be affecting the resistance. So in case I have the bigger area, think like a broad area and thin area. Okay, so a road. Okay, so when the car is moving from one end to another end, first case length is more, it's difficult. Second case, area is more, easily we can come. Okay, when we are driving with the thin road and like a big thick rod means, so second case we easily will come at the another end. Okay, so when the area is increased, resistance will get decrease, so we can have inversely proportional. So resistance inversely proportional to area. The first case, resistance directly proportional to area. Second case, resistance inversely proportional to area. Then nature of material, it's very simple. Nature of material, so nature of material, so it is copper. Copper is a good conductor, we know already, it's very easy. Copper is a good conductor, so good conductor usually have the resistance will be the less. Okay, the conductance will be more. Conductance will be more. Okay, we will take it another thing, wood or mica or something. The resistance will be high, very high. It's because it's bad conductor. The conductance will be less. Okay, that's way factor will be affecting the resistance. The next one, temperature. How the temperature will be affecting the resistance? If the temperature increase, okay, so all the molecules will start to vibrate. It will offer more resistance. Okay, so the temperature will be directly going to affect with the resistance. Okay, so I'll repeat again. Length is direct, resistance directly proportional to the length, resistance inversely proportional to the area. Okay, good conductor have less resistance, bad conductor have more resistance. If temperature increase, resistance will be increasing. Okay, now comparison, resistance directly proportional to length, inversely proportional to area. Okay, like when we are removing the directly proportional, already I told you, you should include the constant. Okay, so resistance is constant here, constant times of length by area. Okay, here what is a constant? Here constant I am going to introduce as the new term, which is called resistivity. So resistance is equal to resistivity times of length by area. It's very simple. Okay, if you are taken this side as the area and this side as the length, you can get what is the resistivity. Cross multiplication you can do it. Okay, so like this you can get what is the resistivity. So length I am taken as denominator, area I am taken as the numerator, which is going to call us the resistivity. So resistivity is equal to resistance times of area by length. So what is resistance unit? Resistance SI unit will be ohms. Area unit will be length into breadth, meter square. Length unit will be meter. Meter square get cancelled. So now we'll get resistivity unit will be ohm meter. What about conductivity? So conductivity inversely proportional to resistivity. So it's opposite to the resistivity. So conductivity inversely proportional to the resistivity. So conductance inversely proportional to the resistance. Conductivity inversely proportional to the resistivity. So unit of conductivity. So which is going to be 1 divided by ohm meter, opposite to the resistivity. So from denominator, if you are taken as numerator, ohm inverse, meter inverse, which is going to call as the conductivity as a unit. Okay, now resistance. What is the unit of resistance? Ohms. Conductance, ohm inverse. Conductance, ohm inverse. Simple. Okay. Resistivity. Resistivity. Resistivity unit ohm meter. What about unit of conductivity? Conductivity. Ohm inverse, meter inverse conductivity. Okay. The next one. Resistance unit ohm, conductance unit, conductance opposite to the resistance ohm inverse. Resistivity unit is ohm meter, conductivity unit is ohm inverse, meter inverse. Okay, now so still so far we got what is the resistance, resistivity, conductance, conductivity. So now resistance in series. Okay, so three resistance I am taken in series, R1, R2, R3. I applied with the battery. So battery we can take it as a BT battery. Okay. So in series current is constant. That you should keep it in mind. In series current is constant. So current is constant in series circuit. Constant. Okay. Now we can have voltage going to be divided. In case I applied as a 9 volt. So V1 volt, V2 volt, V3 volt. 3 volt is getting divided. Current in series constant. Okay. So if in case if you apply 9 volt, that's going to divide into 3 plus 3 plus 3. So totally 9 volt, like that only. Okay. So total V net is equal to V1 plus V2 plus V3. So according to Ohm's law, V is equal to IR. So V is equal to IR. IR total IR1 plus IR2 plus IR3. Why it is like this? Because the total voltage V is equal to IR, I know. Okay. All the cases I am not taken R as separately. R total I am not taken separately. I1, I2, I3 because in series current is constant. No need to differentiate. But resistance different, voltage different. So all I get cancelled. All I get cancelled. So R total is equal to R1 plus R2 plus R3. So total resistance will be like this. Okay. Yeah. Next, I'm going to do with it is resistance in parallel. Hello. Yeah. Resistance in parallel. So resistance in parallel. Resistance in parallel. You should keep one thing in your mind. Okay. Resistance in parallel. Voltage going to be constant. So voltage is constant in parallel. That you have to keep it in your mind. So I have same three resistance R1, R2, R3, three resistance. So I connected with the battery. So I told you already voltage will be constant in parallel, current will be constant in series. Okay. So R1, R2, R3. Here current is not a constant. So I current is going to divide I1. Here will be I. Okay. So when it's coming in this junction, it's going to divide I1, I2, I3. So all the three current is going to add here. Again, it's going to come as I current. Okay. So current will be different. Voltage will be getting same. Voltage will be constant in parallel. Okay. So total voltage, net voltage is equal to V1 plus, sorry, total current is equal to I1 plus I2 plus I3. Why we should add current here? Because here voltage we are not able to add because voltage is constant. So I know V is equal to IR. I is equal to V by R. Ohm's law. Okay. So V divided by R total. Here it's parallel. V divided by R1 plus V divided by R2 plus V divided by R3. All V is the same only. You can cancel. Yeah, all the voltage will be the same. You can cancel all the voltage. So 1 divided by Rp is equal to 1 divided by R1 plus 1 divided by R2 plus 1 divided by R3. So resistance in parallel we got. Okay. So resistance in series already we know. R in series R1 plus R2 plus R3. Now we learned what is resistance in parallel. Okay, both the calculation we learned now. Okay. Next thing, energy. Okay, energy formula. So energy formula and power formula. So it's a very important content only we are discussing. Okay, energy. So voltage is equal to work done by charge. Charge, if you are taken this side, voltage work done is equal to charge into voltage. Charge into voltage into charge, or charge into voltage. Work done we can call as the energy. So energy is equal to volt into charge. Okay, now we are doing four formulas from energy. Okay, so I know current is equal to charge by time. Charge by time. If you are taken time this side, charge is equal to current into time. So charge is equal to current into time. So we are going to substitute charge is equal to current into time. So energy is equal to VIT. VIT, Vellore Institute of Technology, like that also you can remember this value. It's a energy equation, first equation. It's very important for class 10. Okay. So I know V is equal to IR. V is equal to IR. Okay, just if you have to substitute. So four formulas from energy we are going to discuss. So energy is equal to IR into IT. I we can write as the I square. So energy is equal to I square RT. It is a second formula, energy formula. Second formula we have now. Okay. Now I know I is equal to, according to Ohm's law, V is equal to IR. So from this R, if you are bringing denominator, I is equal to V by R will come to know. So I is equal to V by R. Just you have to substitute here. So energy is equal to V square by R square because of whole square into R into T. So R get cancelled. So what is energy? So energy is equal to V square by R into T. So now I got what is the energy formula. So finally I'm going to write what is the energy formula. Energy is equal to VIT I square RT V square by R into T. So energy formula, four formulas we got. Next, power formula I am going to learn. What is power formula? Power is very simple. Power is energy by time. Power is energy by time. So all the formulas you should divide it by time. So power is equal to VIT divided by T. First equation. Energy equation. Energy by time is power VI. Second formula. Power is equal to I square RT divided by T. T get cancelled. The power is equal to I square R. Next, third formula. Power is equal to energy by time. V square by R into T divided by T. T get cancelled. V square divided by R power. Okay. So finally we got three power formula. Power is equal to VI I square R V square by R into T. So I'll get what is now power formula. So I got three power formulas, three energy main formulas we got. Okay. So the next is unit. So power unit, we can take it as a watt. Watt is a power unit. Okay. So energy unit we can have joules. Okay. So unit always will get confused. See here, power is equal to energy by time. So if you are taken time that side, energy is equal to power into time. Energy is equal to power into time. What is energy? Joules. What is power? Watt. What is time? Second. So 1 joule is equal to 1 watt into 1 second. Power is equal to, power into time will be the energy. That's a very important notation. Okay. See here, now it's a very important value. 1 kWh, kilowatt hour, is equal to dash. Okay, actually first of all we will be doing with conversion. 1 kilowatt is how many watt? 1000 watt. 1 hour is how many seconds? 60 into 60 seconds. So finally we have 3600 into 1000, 3 zeros extra. Watt second. Watt second is what? power into time. Power into time, what second is going to be the joules? So 3006,000 zeros, watt second we can have joules. So 1 kWh is the indication of the energy. So 3.6 into 10 power plus 6 joules. So I got what is the energy. Okay. Now again, some of the conversion you need to know. 1 kilowatt hour is equal to dash watt hour, 1000 watt hour. Okay. It's the unit of energy. Okay. 1 hour is how many seconds? 3600 seconds. This and all some extra points you need to know. 1 kilowatt is equal to dash 1000 watt. Okay. Milliampere is equal to how many ampere? 10 power minus 3 ampere. This and all it's required to do the problems. Okay. So millisecond is equal to dash second, 10 power minus 3 seconds. That's and all it's required for doing the problems. Okay. So now we learned energy, current electricity, many of the concept which is based from the 10th standard. Okay. So it's a main content is there in the 10th standard. Okay. Next we are going to discuss about the graph. Okay. So graph, x-axis, y-axis, I am taken current and voltage. So directly proportional. No? We'll get straight line for the metal conductor. Okay. Conductor, it will be the straight line because it is directly proportional. V is directly proportional to I for the conductor. Okay. In case if you are getting like this, it is not going to obey the Ohm's law. This graph is not going to obey the Ohm's law. It's not a conductor. Okay, it's not a good conductor also we can say. Okay, there are two types of graph is there. First graph which obeys the Ohm's law. Second graph which is not obeys the Ohm's law. Okay, so this is the this and all will be help you to do in a 10th standard. Okay, so 12th standard notes I'll give separately. Okay, thank you for watching my video. If you like my channel, please subscribe. Thank you everyone.